Okay, let's continue to look at slope. Previously, we learned how to find slope from a graph, and today we're going to be talking about tables. So when calculating slope from a table, the change in y is over the change in x. So if you remember when we were doing the graph part, when we moved up and down, that's the change in y, right? Because the y-axis is vertical. And when we built the part side to side, the run, that's the change in x. So the rise is the change in y. And the run is the change of x. I put x like that. So the triangles, I'm going to change this. I guess I'll put the triangles in. So oftentimes when we write change in x, we don't actually write out the word change. We use the delta triangle. So I'm going to insert a special character here. So we use this triangle to represent the word change. Okay. So the triangle just means the change in. So we can use the delta triangle in place of the word change. In order to be linear, each rise over run must be fractional equivalence. So, when we were looking at a graph, it was pretty clear if something was linear because the graph was a straight line. When you look at a table, it may not be as immediately noticeable if the relationship is linear. So we would have to look at each rise over run or each change in y over change in x. Those words are interchangeable. And they must be equivalent fractions. They all must simplify to be the same fraction in order to be considered linear. So if it's stated that the table represents a linear relationship, any two coordinate points from the table may be used to calculate slope. So when you're looking at a table, that is what comprises a table, is coordinate points of the relationship. So if we took those coordinate points and we graphed them, if it was linear, we would get a straight line because that's what we know what a graph looks like when it's a linear equation. But we're not going to be able to graph all the time. Sometimes we're just going to have the table, and that's when we have to determine each rise over run from one point to the next and make sure that those differences are fractional equivalents. But just like on the graph, when we said it didn't matter which 2 points we chose, as long as they lied on the graph, we would get the slope. If the table is linear, it doesn't matter which 2 points from the table that we choose, we should still get the same fractional relationship. So what does this look like? This is a table, and I just use these little knots here to determine this is where I'm going to find the change of. So I would go through and find all of my changes from -2 to -1. That's going to be the same as +1. From -1 to 0, that would be +1. 0 to 1, +1. From 1 to 2, +1. So these are the changes in x. Down below, from 8 to 5, I'm changing by subtracting 3. From 5 to 2, I'm going down by 3. Going down is a negative. From 2 to -1, I'm going down by 3. Relash. And from -1 to 4, I'm going down by 3. So remember, it's the change in slope is made up from the change in y over the change in x. So a negative divided by a positive would be a negative, and so it would be 3 over 1, or just -3 would be considered the slope. Now imagine if I didn't have this point here, the -1 and 5, and I had to go from 8 to 2. I would have gone down by 6, and from -2 to 0, I would have gone up by 2. And -6 over 2 still would simplify to be -3 over 1. So this is how you find the slope from a table. And you have to, 2 GP pages. I'm going to go zoom back out so you can kind of see them a little bit better. So you have to find this. These are all linear relationships on your first GP 14. You have to find the slope of each linear equation represented in the table. On GP 15, it asks you determine if each table below represents a linear relationship. So you're going to have to go through and find every single change to determine if it's linear. And if it's linear, then what's the slope? Also, if it's linear, you're going to take one of these circles and put it around yes, and then determine if it's a function, because there's, not to say every linear relationship is a function. So if it's a function, you're going to say yes. If it's not a function, you're going to say no. Also, remember, there are functions that aren't linear. So you can have something on here that's not linear, and it will not have a slope, but it is in fact a function. So those are the questions you need to ask yourself on GP 15. And that is finding slope from a table.